Hi there. This video is an exam paper walkthrough of the AQA GCSE Mathematics Foundation Tier Paper 1 from summer 2023. This paper is worth 80 marks in total, and this is the fourth video of 4. It will focus on questions 19 to 25, which account for 24 of these marks. AQA paper 1s are non-calculator, so a calculator cannot be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 19. Andrew and Bruce share some money in the ratio 5 to 6. So we've got Andrew and Bruce, 5 to 6. I'm just going to label my ratio so I know which part is Andrew and which side is Bruce. Bruce gets £96, so Bruce, his part of the ratio is worth £96. So I'm going to put that there in the correct place because it might help me later. Andrew gives 1/4 of his share to Carl and Bruce gives 2/3 of his share to Carl. How much money does Carl receive? Okay, well, we know Bruce has got £96, so we can find out 2/3 of 96 straight away. So Bruce gives Carl, okay, so he's going to give him 2/3 of 96. So when we're finding a fraction of an amount, we divide by the denominator and we multiply by the numerator. So 96 divided by 3 is 32, maths brain. And then 32 multiplied by 2 is 64. So Bruce gives Carl £64. All right. Andrew gives Carl 1/4, but we need to find out how much Andrew got to start off with so we can find 1/4 of that. So we need to figure out what we do to get from 6 to 96. Well, with ratios, we need to remember it's a multiplicative relationship. So we're scaling up. Okay, we're using a multiplier. So we're going to start by doing 96 divided by 6. 6, 12, 18, 24, 30. 6 into 9 is 1. Remainder 3. 6 into 36, 1, 2, 3, 4, 5, 6. All right, so we've multiplied by 16. So we're going to multiply by 16 on the other side to find out how much Andrew got. So 5 times 10 is 50. 5 times 6 is 30. Add those together tells us that Andrew got £80. He gives 1/4 of that to Carl. So Andrew gives to Carl 1/4 of 80. So 80 divided by 4 is 20. So Carl gets 20 plus 64. So Carl gets £84 in total. Question 20. Players score points in a game. The scatter graph, so this diagram here, shows the time played and the points scored by some players. So the time played is the horizontal axis, the points scored is the vertical axis, and there's some data points being plotted for us. 20A, circle the strength and type of correlation shown. Now what we can see here is all of the points are travelling in an upwards direction. They're giving, if we were to draw a line to represent those points, a line that took the average, that line of best fit that we use for scatter graphs, it would have a positive gradient. Okay, so it's definitely a positive correlation, and the fact that the points are quite closely clustered together means it's a strong positive. If they're a little bit more spread out, then it would be a weak positive, but they are quite close together. In fact, it wouldn't be much closer before they did actually look like they were a straight line. So we're confident with strong positive there. 20B. Players get 1 extra life for every 2,000 points they score. Jonah plays the game for 15 hours. Use a line of best fit to estimate the number of extra lives he gets. So we're going to have to draw that line of best fit. So that line that I said describes the trend of this data. So the thing about a line of best fit is it doesn't have to go through all the points, but it does have to show the trend of the data. So you want it to be roughly in the middle of everything when they're clustered like this, and you want to follow the trend. So I can't draw a line of best fit across there because it's not following the appropriate gradient, trend or slope of this data. Same as I can't draw one down here because again it would be going in the negative direction and we want a positive correlation. So roughly central, and then make it cover the whole of your graph. So it just needs to cover the same trend as that graph. It doesn't have to be perfect. And then we're estimating the number of extra lives that he gets. Okay, so he's playing for 15 hours. So here's 15 hours on the graph. So we're going to draw a line up to our line of best fit. And then where it meets our line of best fit, we're going to draw across and read off the scale there. So this is the number of points in thousands. So that's around 35. It's midpoint between 30 and 40. 35,000 points. So he gets 35,000 points. They get one extra life for every 2,000 points they score. So let's divide this by 2,000. So I can divide top and bottom by 10, by 100, by 1,000, okay? So 35 divided by 2 is 17.5. So one extra life for every 2,000 points they score. So he's going to get 17 extra lives. Question 21. So we're given a number expressed as a product of prime factors. 2 to the power of a multiplied by 3 multiplied by 5 squared equals 600. And they want us to work out the value of a, and you must show you're working out. So I'm going to do this by writing a prime factor tree for 600, and I'm going to take it from there. I'm going to write a product of primes from my prime factor tree, see how it matches up here. So when we're doing a prime factor tree, just start with any two numbers that multiply and give you 600. So I'm going to go with 2 and 300. 2 is a prime number, so I'm going to circle it and end that branch. Now I need to continue on the 300 branch. So two numbers that multiply to give me 300 as a product. So let's do 3 and 100. 3 is a prime number, so I'm going to circle it. That branch has ended. I need to continue the 100 branch. Same again, two numbers that multiply to give me 100. I'm going to go with 2 times 50. 2 is a prime number. Now I need to continue the 50 branch. I'm going to go with 2 times 25. And then I'm going to go with 5 times 5 for 25. So if I was to write this as a product of prime factors, I would write 2 times 2 times 2 times 3 times 5 times 5, which is 2 cubed times 3 times 5 squared. So I'm going to compare this with this product up here. So I have the 5 squared, I have the 3, but the thing that's missing is the power on the 2. So A must equal 3. So I'm going to put 3 on the answer line. Question 22. Expand and simplify fully. So I'm going to expand this bracket and then this bracket, and then I'm going to simplify the answers that I get. So I'm going to use the grid method to expand. You might use a different method, whichever method works for you. So the 5 goes on the outside, and then the brackets are 3x add 4. This is a multiplication grid. It's also known as the area model, so that might be something that you're used to hearing. 5 multiplied by 3x is 15x. 5 multiplied by positive 4 is positive 20. I'm going to do the same now with this bracket. So I've got negative 2, because that sign in front of the 2 there belongs to it. It stays with it. So negative 2 multiplied by x subtract 1. So negative 2 multiplied by x is negative 2x. And negative 2 multiplied by negative 1 is positive 2. Negative multiplied by a negative becomes a positive. 2 times 1 is 2. So now these values inside those grids, those area models, I'm going to take out. So I've got 15x add 20, and then minus 2x. Remember that sign in front stays with it, plus 2. And then I'm going to collect like terms. That's the simplifying part, guys. So I've got 15x minus 2x, remembering to keep that negative with that 2x. So 15x subtract 2x leaves me with 13x, and then 20 plus 2 is 22. So this expansion simplifies to the expression 13x plus 22. Question 23. Erica tries to sketch the graph y equals 1 over x with x not equal to 0. So y equals 1 over x is an inverse proportion graph. Here it is. That's Erica's sketch. The question says make 2 different criticisms of her sketch. Criticism 1 for me is that the graph touches the y-axis. With the inverse proportion graph, okay, with the reciprocal graph, that graph should never touch the axis, y or x. It gravitates towards it, but never quite touches it. So, just pop there, the graph should not touch the axes. The sketch touches the y-axis. Okay, so that's my first criticism. My second criticism is this part. So this part of the graph is in the wrong quadrant. It should actually be in this quadrant here. So I'm just going to say for criticism 2 that the curve in the top left is in the wrong quadrant. Don't need to explain more than that because I've drawn it where it should be. It should be a reflection of the other graph. Question 24. Sunita is X years old. Beth is 1 year younger than Sunita. Joel is double Sunita's age. The mean of their ages is 5. How old is Joel? Okay, so we're not given any values here apart from Sunita is X years old. So we're going to use algebra, we're going to form some expressions, and then we're going to use them to solve this problem. So if Beth is 1 year younger than Sunita, Beth must be X subtract 1. So B equals X subtract 1. If Joel is double Sunita's age, Sunita is X, so Joel must be 2X. Okay, so Joel is 2X. The mean of their ages is 5. So when we're finding a mean, we add everything together and then divide by the number of data values that we've got. So we would have added Sunita's age, X, to Beth's age, X minus 1, to Joel's age, and then we would have divided by 3 because those are the 3 ages that we have. Okay, so I'm going to simplify the top of this here. X plus 2x. So 1x plus 1x is 2x, plus 2x is 4x. But I've still got that subtract 1 I need to be aware of there. And I'm still over 3. Now I'm going to multiply both sides by 3. So 4x subtract 1 equals 15. I'm going to add 1. So 4x equals 16. And then I'm going to divide by 4. So x equals 4. So if x is 4 and Joel is 2x, Joel must be 2 times that. So Joel must be 8 years old. Question 25. Work out 2/3 divided by 4/5. Give your answer as a mixed number. So 2/3 is a mixed number, so I'm going to convert that to an improper fraction to start off with. So 2 multiplied by 3 is 6, add 1 is 7. So that becomes 7/3, as an improper fraction, and I don't need to do anything to change 4/5 at this moment. Now 7/3 divided by 4/5, I need to change this into a multiplication. So I'm going to keep 7/3 as it is, and I'm going to get the reciprocal of 4/5 because that means I can change this sum into a multiplication. The reciprocal of 4/5 is 5/4. You flip the fraction upside down, and then we can multiply the fraction. So numerator multiplied by numerator, denominator multiplied by denominator. So 7 multiplied by 5 is 35. 3 multiplied by 4 is 12. Now this currently is an improper fraction because the numerator is bigger than the denominator, and it wants our answer as a mixed number. So we need to see how many 12s go into 35. 12, 24, 36. Well, 2 of them into 35, and the remainder from 24 to 35 is 11. So that goes on the top of our fraction for our answer there. So 2 and 11 12ths.